Okay, so today we're doing section 5.2, which is linear equations in 3 variables. So you're going to have 3x3 systems for the most part. And we don't graph things that are 3-dimensional because we have 2-dimensional paper. But like when I was in high school, they made us do a project where we had to like take the corner of a box and use yarn and to graph these. So you really do get like, they call them linear, but they don't really make lines equations that have 3 variables. They make planes. But like geometric planes, not the plane that flies. Anyway, so section 5.2, we are solving systems just like what we did in section 5.1, except that there's more to it because there's more things to find. But it's the same concepts, you just have more to do in a problem. Alright, so first of all, just to show that something is a solution, you just have to show that it works in all of the equations. So, checking the first equation, we have negative 1 for x minus 2 times negative 4 for y plus 3 times 5 for z is 22. So if you do all of this, do you get 22? So let's see, we do negative 1 minus 2 times negative 4 plus 3 times 5 in our calculator. I apparently can't type because my calculator says you can't do that. Okay, so you do get 22. So it checks out. So then we check the next one. So we do 2 times negative 1 minus 3 times negative 4 minus 5. Do we get 5? Well, 2 times negative 1 minus 3 times negative 4 minus 5 is 5. So that one works out. So now we check the last one. 3 times negative 1 plus negative 4 minus 5 times 5 should be negative 32. Alright, so if this didn't work out, we could have stopped and said no. If this didn't work out, we could have stopped and said no. Since both of these work, we have to check the third one. And when we check that, we get negative 32. So it also checks out. So as long as they all check out, then you can say yes, it's a solution. And there will be one not simple on your test. Can you plug it in and tell me yes, they all work? Okay, so once we work problems, these steps will make a little bit of sense, and I may not follow them exactly, so I wouldn't try like writing it all down. You have the notes where you can print this out, so I wouldn't write all of these steps down. Just read through them and then watch me work some examples. Alright, so our goal is to whittle it down to a 2x2 system. So the first thing I'm going to do is pick 2 of my equations where I can put them together and get rid of a variable. Sometimes it happens really easily, sometimes it requires some work. But if we look at the first 2, I can put those together. Now just to help follow along and know what's happening and for me to be able to follow your work, I need to know what you're thinking. So I like to label my equations. So they gave me equation 1, equation 2, equation 3. So my first thought is I can just add equation 1 to equation 2, and I'm going to get rid of the z's. So we just add these together, we get 4x plus 6y, no z's, equals 28. Now this hasn't helped me other than I have a shorter equation. So I'm going to call this equation A and hold on to it for a minute. Alright, so now I'm going to go back and I either can put 1 with 3 or 2 with 3, and I have to get rid of z again, because if I get rid of a different variable, I'm not going to have something that matches this, and I've wasted my time. So put 2 other equations together and get rid of z. So I think that I can do 1 and 3. If I add 1 and 3 together, I'm not going to get these to cancel unless I make this a negative 2. So I'm going to take equation 1 and times it by 2, which will give me 2x plus 8y minus 2z equals 40. I'm not going to change equation 3, so just write it down. Now when I add those together, I get 4x plus 5y equals, because those cancel, what is that, 24? Alright, so we'll call this equation B. Alright, so now I have a little 2 by 2 system. 2 equations, 2 variables, both of them have an x and a y. So I can put A and B together. But if I put A and B together, I'm going to get 8x and 11y. I need one of those to go away. So I think I can get the x's to go away pretty easy if I just take one and multiply it by a negative. So if I take the A and multiply it by a negative, it becomes negative 4x minus 6y equals negative 28. If I add B to that, these cancel. This gives me negative y equals negative 4. So y is equal to 4. Wow, that was drastic, sorry. I don't know why this is being so weird. Okay, that's really all I wanted. Wasn't enough room to say y is 4. Alright, so we finally know something that's helpful. So I know one piece of information. So I can take about one piece of information and I can plug it in where there's 2 pieces. Now I can plug it in here or here, but this is where I have room to work, so I'm just going to do that. So I'm going to take my value for y and put it into equation B. So that's going to be 4x plus 5 times 4, because that's what we found out y is, equals 24. So 4x plus 20 equals 24. So 4x would be 4 if we subtract 20. So dividing by 4, we get that x is 1. Alright, now I know 2 things. So if I know 2 things, I plug it in somewhere where there are 3 things. So I can take the x and the y that I now know and plug them into any of those original equations. I'm going to pick 2 because it has a positive plain old z. That's the only reason. You can pick any of them. So we're going to do 3 times 1 plus 2 times 4 plus z equals 8. So 3 plus 8 plus z equals 8. 8, 9, 10, 11 plus z equals 8. Subtract 11, so z is, what is that, negative 3? Alright, so we now know all 3 things. So the answer is an ordered triple, and you put them in alphabetical order, x, y, z. So ultimately, that is our answer. Alright, now I know this is a lot. It's nothing difficult ever. It's just a lot of steps. Alright, so sometimes they're going to give you problems where they've kind of helped you out a little. So if you look at this one, you see that this first equation only has 2 variables. So when I make my choice about what to put together and what to get rid of, they've kind of already made that for me. I should put 2 and 3 together, and I should get rid of the x's so that I have somebody that matches this. Alright, so we're going to take equation 2 and 3, and we want to get rid of x. So if I want this to cancel, I've got to have a negative 2 here if it's going to cancel with that positive 2. So I'm going to times by negative 2 so that I have negative 2x, and then minus 4y minus 2z equals negative 34. Alright, so we're not changing equation 3. Alright, so our goal was to get rid of the x's. That happens. We get negative 7y. We also nicely got rid of the z's. So this is negative 35. Put these together, you get negative 35. Divide by negative 7, and we already know that y is 5. Alright, so you know one thing. You got to plug in one thing where there's 2. The only equation we have right now that has 2 variables is equation 1. So you got to plug y into equation 1. So we have 2 times 5 minus z equals 7. So 10 minus z equals 7. Subtract the 10, so negative z equals negative 3. So z is 3. All right, now that you know two things, you're going to plug it in where there are 3 variables, and you can plug it in to equation number 2 or equation number 3. I'm going to pick equation number 2. And again, my reasoning for that is that it has a plain old x, which makes things a little easier, but it's not important that you pick that one. All right, so we have x plus 2 times 5, because that's y, and then plus 3 for z is equal to 17. So x, this is 10 plus 3, so 13. Subtract the 13, and you get 4. So we now know x, y, and z, so we are done. Write that as an ordered triple. And that is the solution. All right, so the people at Bitsy thought that those 2 examples were enough. I have a couple of more just to make sure that everybody knows what's going on. In class, I'm going to have them try this one. So go ahead and pause the video and give this one a try and see how you do. And you can unpause and see if you have the right answer. Or if you get stuck, you can unpause and see what I did. Keep in mind that your choice of what to do and my choice of what to do may not be the same. These are one of my least favorite things to grade because I have to look at every single thing that you did, which is why I like for you to give me a little roadmap of telling me what's going on. Because you may not work it exactly the same way as me, but that doesn't mean you're going to end up with the wrong answer. But if you do have the wrong answer, and I'm going back to check, I have to look at every little thing you did because usually it boils down to someone like lost a negative somewhere. All right. So looking at what I have, you have opposite signs with the y's and the z's, so you could get rid of either one of those. One is not going to be any easier than the other. So we got rid of z earlier, we'll get rid of y this time. So I'm going to put 1 and 2 together and get y to go away. This is negative 3, so I need this to be positive 3, so I'm going to times that 3. So it'll be 6x plus 3y minus 6z is equal to negative 3. And I don't need equation 3 to change, so I'm going to write down exactly what it says. So we get 9x, y's cancel, minus 7z is equal to 2. Call him A and hang on to him for a minute. All right, so now I got rid of y. You got to do it again. So I did 1 and 2. I'm going to go back and use 1 again and combine it with 3. And the reason for that is anytime you can use something that has a variable without a coefficient, it's going to make things easier. It's less steps involved. All right, so if I multiply by 2, so this is 2y to cancel with this negative 2y, we're going to have 4x plus 2y minus 4z is equal to negative 2. Then we'll have x minus 2y plus 3z is equal to 6. Add those together, you got 5x, no y's, minus z is equal to 4. So call that b. Alright, so your equation A and your equation B, when you get down to having an A and a B, they should match. They should have the same 2 variables. Alright, now our goal is to put those together and get rid of something. It, again, does not matter. I'm picking the z's because I only have to multiply one of the equations to make those opposite. So I can take A and add b to it. If I multiply by 7, those z's will go away. So A is going to stay. 7 times 5 is 35. And 7 times 4 is 28. Okay, so I actually just missed something. These have the same sign. So in order to make them cancel, I should have multiplied by negative 7. So I need to change the signs and everything there. Alright, so we're going to get negative 26 x, those cancel, equals negative 26. So we get that x is 1. Alright, you know one thing, so you've got to plug it in where there are 2. And again, it does not matter which one of these you plug it into, A or B. I'm going to pick B because it's right there and I can see it without much effort. So 5 times 1 minus Z equals 4. So this is 5, subtract it to the other side, so negative Z is negative 1, so Z is 1. Alright, now I know 2 things, so I'm going to plug it into an equation that has 3 variables. Since I'm trying to find Y, I'm going to plug it into equation 1. Again, it doesn't matter, that's just my preference, because it doesn't have a coefficient on the Y. Alright, so we're going to do 2 times 1 plus y minus 2 times 1 equals negative 1. So 2 plus y minus 2 equals negative 1. So 2 minus 2 cancels, so this is just y equals negative 1. So we have found all 3 things. Remember to put them x, y, z, and you're done. Alright, so again, hold on real fast. There's so many of these. I don't think we need that many examples. We'll skip this one, and this one, do this one. Alright, so here's another one for you to try. If you need for me to work those 2 that I just skipped, if you're still not real sure about what's happening, please email me, and I will make another video working those 2 problems and share that with you. But me working a bunch of them is not going to usually help. You need to try them on your own and ask me questions about, like, I didn't get the answer the back of the book has. Can you see if you can find a mistake because I can't? Like, that's really the most beneficial. I'm happy to work those other 2 though if you need me to. Alright, so pause and work this one. See how you do. Alright, so alright, so we have one that only has 2 variables. So I need 2 and 3 to combine and get rid of the z, which actually works out nicely because the z's are just going to cancel if I add them together as they work. So if I take this and this, everything does not cancel. The z's do cancel, is what I was trying to say. So we get an equation A that has the same variables in it as 1. So I can go ahead and put A together with 1. And I want to get rid of a variable. Do you want to get rid of x? Do you want to get rid of y? It really doesn't matter. If you multiply by negative 2, you can get rid of the x's. If you multiply by negative 3, you can get rid of the y's. I'll multiply by negative 3. So equation A stays the same. Equation 1, you're going to have negative 6x minus 3y equals negative 6. So negative 2x, y's cancel equals negative 2. So x is 1. Alright, so we know that x is 1. You can plug that into equation 1. You can plug that into equation A. Equation 1 looks a little simpler. So we'll take x and put it into 1. So 2 times 1 plus y equals 2. That's 2. Subtract it. Y is 0. Alright, now you know 2 things. So plug it in somewhere that there's 3 things. So you can either choose 2 or 3. And we'll go with 2. But that's not what I meant to write. We want x and y to go into equation 2. So we have 1 plus 0 minus z is 4. So subtract the 1, negative z is 3. So z is negative 3. Once you know 3 things, you just write it as an ordered triple. X was 1, y 0, and z negative 3. Alright, again, if you need those other 2 examples worked, please let me know. Otherwise, just try the homework problems, and if you run into some where you're not getting the same answer that the book got, then send me an email with a picture of your problem, and I'll see if I can figure out what's going on.